Here's the video for the Unit 8 practice test. So the first question says you want to compute a 95% confidence interval for the population mean. It tells us to assume the population standard deviation, which is sigma, is known to be 10 and the sample size is 30. So it says what is the critical value to be used in this calculation? So first thing we need to figure out is if we're using Z or T. So if we go back to that flow chart, first question is population mean or proportion. In this case, it says means. So we know that we're going to be looking at means. And in order to use, or to look at what critical value you would use for means, you have to have the population standard deviation, which we have, and our sample size has to be greater than or equal to 30, which is 35. So that tells me that we're going to use Z star for this situation. So if we look at our table, the 95% confidence interval Z star critical value is going to be 1.96. All right, the second question says if we didn't know the population standard deviation, what would the critical value be? In that case, we would have to use T star. And for that, we would look under degrees of freedom being at 34, and we would look at our T table. So that's going to be 2.042. So when we look at our T table, since we don't have 34 on the table, we round down to 30. So that's where you would find the 2.042. All right, next question is basically asking which was the correct interpretation for that confidence interval. So remember that, so the correct answer is C, and remember that when we interpret a confidence interval, when we refer to being a 95% confidence interval, that means the proportion of the confidence intervals would capture the true mean that percentage of the time. So we say if the procedure were repeated many times, 95% of the resulting confidence intervals would contain the population mean systolic blood pressure. All right, the next question is basically asking what happens to the confidence interval if we increase the confidence level. So when we increase confidence level, remember that our confidence interval gets wider. Okay, so if our confidence interval gets wider, that would mean by default we would have a smaller risk of being incorrect, meaning we are more likely to capture the true mean. Think of it this way, right? If you want to be very confident that you're going to make a shot into a basketball hoop, you're going to make that hoop very, very big. So that's the same thing with a confidence interval. When we increase our confidence level, we make it very, very wide. And when it's very, very big, our hoop is very big, it's a smaller risk of missing or being incorrect. So that's why we would say that it would make a wider confidence interval and would involve a smaller risk of being incorrect. All right, question number 4 is asking for the standard deviation of the sample proportion. So we're looking for the standard deviation of the sample proportion. Remember the formula for that is going to be p hat times 1 minus p hat over n. Or if you're given p, you would use p. But in this case, we have a sample proportion. So this right here is p hat. So it's going to be 0.25 times 1 minus 0.25 over 200. So when you put that in your calculator, it's 0.0306. So when we round, that's going to be 0.03. All right, the next question is asking about conditions. So it gives us a situation where a radio host is asking or is interested in estimating the proportion of adults who think the drinking age should be lowered to 18. So he asked the question to his listeners if they think that the drinking age should be lowered, and then he asked listeners to vote in and vote yes if they agree that the drinking age should be lowered and no if not. So it's asking which conditions, if any, are not met. So let's just go through the 3 conditions. So the first condition is the independent condition. Big N is greater than or equal to 10N. In this case, big N represents the population, which in this case would be all listeners. It's greater than or equal to 10N. So 100 is our sample, so that's 1,000. So it does say that we have a large audience, so that's reasonable to assume. So the independent condition is met. Okay, the normal condition, we're going to do N times P hat. So in this problem, P hat is 70 over 100, which is 0.7. So it's going to be 0.7, or let's do it this way, 100 times 0.7, which is 70, which is greater than or equal to 10, so that's good. And then we're going to do 100 times 0.3, which is 1 minus 0.7. That's 30%, or sorry, 30. That's also greater than or equal to 10, so that means it's approximately normal. So the normal condition is met. Lastly, the random condition, we're looking for how our sample was chosen. Well, our sample was chosen by asking listeners to vote in. So in this case, it is not normally distributed, or not randomly selected, because it's a convenient sample. So the condition that is not met is the random condition. All right, so question number 6 is asking us to calculate a 98% confidence interval. 98% confidence interval for the mean yield. It gives us some information. It says that we have an average of 213.429 grams per 400 meters squared yield of barley, and it gives us a sample standard deviation of 52.141. It tells us we have a random sample of 17 fields. So in this case, it's telling us don't worry about checking the conditions. So we're just going to do a regular confidence interval. So first thing we need to do is determine if we're going to be using Z or T. Well, in this problem, I know it's about means because it says mean there. In order to determine if we're going to use Z or T, we have to see if we're given our population standard deviation. In this case, we are not. So in this case, we're going to use T star because we're using means. We don't have sigma. And if we also look at our sample size, n is less than 30, which means that we should be using T star. So our confidence interval is going to be X bar plus or minus T star times S over the square root of n. So let's figure out what these numbers are. So starting with X bar, that's our sample mean. So that's going to be this number right here. So it's going to be 213.429 plus or minus. So now we need to determine the T star value. So in this case, we're doing 98% and our sample size is 17. So I'm going to pull up the T table. All right, so here's our T table. So looking at 98% is, let's see, 98% is this column right here, and our sample size is 17. So our degrees of freedom would be 16, which tells me my T star value is going to be 2.583. So it's going to be 2.583 times S, which is 52.141, over the square root of 17. So now I'm going to put the part after the plus or minus into my calculator. That's going to give me my margin of error. All right, so when we put that in our calculator, we get a margin of error of 32.6647. So the confidence interval is going to be 213.429 plus or minus 32.6647. So to find my lower bound, I'm going to subtract. So that's going to be 180.7643. And to get my upper bound, we're going to add. And we get 246.0937. So my confidence interval is going to be from 180.76. My units are going to be grams per 400 square meters to 246.09 grams per 400 square meters. All right, so in this next problem, we are calculating the margin of error for 90% confidence for the true mean height of males in the United States. So for this particular problem, again, we want to determine if we're using Z or T. So first of all, we know that this problem is about means. In this problem, we do not know sigma. And our sample size is less than 30, which tells me that I'm going to be using t star for this problem. So since we're just doing the margin of error part, remember that the margin of error part is just the part after the plus or minus. So it's just going to be the t star times s over the square root of n. So since I determined that, or figured out that you cannot see my t-table when I pull it up, you're just gonna have to trust me that this is the correct t-star value. So the t-star value for 90% confidence for a sample size of 25, so degrees of freedom would be 24, is gonna be 1.711 times the standard deviation, which is gonna be 4.15 over the square root of n. Our sample size is 25. So when we put that in our calculator, we get about 1.42. So our margin of error would be 1.42. All right, number 8 says you want to estimate the mean SAT score for a population of students with 90% confidence. Assume the population standard deviation is sigma equals 100. If you want the margin of error to be approximately 10, what will your sample size need to be? So this is a working backwards problem since we're determining a sample size based off of a margin of error. So this problem is about means, which means that the formula that we're going to use is the margin of error equals, in this case, we're always going to use z when we're determining a sample size. So z star times sigma over the square root of n. So in this problem, we know we want our margin of error to be 10. The z star value we would use for 90% confidence would be 1.645. Sigma is 100 over the square root of n. So what we're going to do to determine the answer, since this is a multiple choice problem, is we're going to plug these numbers in for n to see which one gives us a margin of error of 10. All right, so the first one I'm going to plug in is 16. So 16 would give us a margin of error of 41, which is too high, so it can't be that one. So now I'm going to try 271. That margin of error gives me 9.99. So it looks like it's going to be this one, but let's just check the other ones just to be sure. The next one is 38. That gives me a margin of error 26. That's too big. Now let's check 1476. That gives me a margin of error of 4.28. That's too small. The last one, 270.6. So that gives me a margin of error of, it looks like almost exactly 10. However, it looks like it's just above. The other thing we need to realize is your sample size should always be a whole number. So in that case, it cannot be E, so that means it would have to be B. So again, when we plug that one back in, 271, it gives me a margin of error of just under 10, which is what we want. We don't want to be over our margin of error. We want to be as close as possible without going over. All right, so now with number 9, this is another one where we are determining a sample size for a specific margin of error. So for this, again, remember that we're always going to use z when we are finding a specific sample size. So in this case, since it is a 98% confidence interval, the z star value we use is 2.326. Okay, in this problem, they give us that sigma is 75. And we want our margin of error to be 20. So we need to figure out what is the n for that. So this problem is about means. So we know that the formula for the margin of error is going to be the margin of error equals z star times sigma over the square root of n. So plugging in everything we know, it's going to be 20 equals 2.326 times 75 over the square root of n. All right, so first thing I want to do is I want to make sure that my n is in the numerator. So we're going to take the reciprocal of both sides. So we have 1 over 20 equals the square root of n over 2.326 times 75. Next thing we're going to do is we are going to get rid of this denominator here by multiplying both sides by 2.3, whatever's in the denominator. So I'm going to multiply both sides by this. So I'm going to go over here. So now we have 2.326 times 75 over 20 is equal to the square root of n. And then the very last step to get n by itself is we're going to square everything. So now we're going to put this part right here in our calculator. So when we put that in our calculator, we get 76.08. Remember, for sample size, we're always going to round up. So that means our sample size is going to be 77. So remember, with these ones, you can always check your answer by plugging it back in to the formula here. So let's double check to make sure that we have the correct margin of error. So I'm going to do Z star, which is 2.326. Times the standard deviation, which is 75, over the square root of our sample size, which we were saying is 77. So that gives us a margin of error of just under 20 points. Notice that if we wrote 76 on this, let's just see what that looks like. That would give us a margin of error right above 20, which is what we don't want. We want our margin of error to be under 20 points. All right, the next question is about the interpretation of a confidence interval. So it's basically asking what we can conclude if we know that the poll had a margin of error of plus or minus 3 percentage points. Well, the correct interpretation would be A. So 95% of all Gallup poll samples like this one will give answers within plus or minus 3% of the true population value. That's just a correct interpretation of a confidence interval. All right, number 11. This is another sample size problem, but this one's a multiple choice problem. So when it's a multiple choice problem, it's a good idea that we can just plug in numbers and see which one gets it. So in this particular problem, we are talking about proportions. So the formula for the confidence interval for a proportion is margin of error equals Z star times the square root of P hat times 1 minus P hat over N. So let's plug in everything we know. So it tells us that we are doing a 95% confidence interval, and for a 95% confidence interval, we would use a Z star of 1.96. So it's going to be 1.96 times the square root, and let's see, it says half the students, so that's going to be 0.5. And then our sample size is n, that's what we're solving for, and we want a margin of error of 0.05 or less. Okay, so I'm going to pull up my calculator and we're going to plug in these numbers and see which one gives us that margin of error. All right, so I'm going to plug in my answer choices. Let's plug in 22. So that gives me a margin of error of like about 21%. That's too much, so it can't be 22. I'm going to plug in 1795. That gives me a margin of error of 0.02. That's too small. So I'm going to plug in 385. Yeah, that looks to be the correct answer. That gives me about 0.05 when rounded, but let's plug in 271 just to be sure. So that's just over 0.05. So in that case, it's going to be the 385. Okay. This is another sample size problem. This one, though, is not a multiple choice one, so we are going to have to do the calculations. So this problem's about proportions, and it tells us, let's see, true proportion equals 0.7. It tells us we want to be 80% confident and then within 0.05 of the true value of P. So that's going to be our margin of error. This is going to be our confidence level, so that's going to give us our Z star, and this is what we're going to use for P or P hat. All right, so the formula for margin of error, just like we saw here, is going to be Z star times square root of P hat times 1 minus P hat over N. So plugging in everything we know, we want our margin of error to be 0.05. Let me do this a little higher. So 0.05 equals 80% confidence for Z star is going to be 1.282. And then we're going to use 0.7, and then 1 minus 0.7 is 0.3 over N. Okay, so first thing we're going to do is we are going to get rid of that Z star, so we're going to divide both sides by 1.282. And in addition, I'm going to go ahead and just multiply these just so it's one number that we're dealing with. So 0.05 over 1.282 equals the square root. So 0.7 times 0.3 is 0.21. Okay, now we're going to square both sides. So now we have 0.05 over 1.282 quantity squared equals 0.21 over N. And then from here, we're going to take the reciprocal of both sides so we can get N on top. So on the left-hand side, we're just going to flip the numerator to denominator. So 1.282 over 0.05 squared equals N over 0.21. And the very last step, we're going to multiply both sides by 0.21. So what we're going to put in our calculator is this part. All right, so when we put that in our calculator, we get 138.05, so we're going to round that up to 139. So N equals 139 consumers. All right, so now with 13, we are calculating a confidence interval for the process mean at the time of each of the crankshafts were produced. So first thing we need to do is we need to decide if we're using Z or T. So this problem is about means because it says means here. In this problem, I'm looking to see if we're given sigma. In this problem, we are not given sigma. However, our sample size is above 30. Or no, sorry, that's not it. Our sample size is 16. The 200 is actually more than 200 is basically our population. So our sample size is 16. So in that case, we're going to use T star for this problem. Okay. So in this case, let's identify our symbols first. So before we identify these things, so our sample size is 16. When we put this data in GeoGebra, I should have mentioned, when we put this data in GeoGebra, there are no outliers, so we're keeping all the data points. I'm not going to show putting it into GeoGebra. X bar is going to be 224.002. Our sample standard deviation is going to be 0.0618. And then the T star value, our degrees of freedom, is going to be 15. And since we are doing a 95% confidence interval, that's going to be a T star of 2.131. All right, first step, we need to identify the parameter. So in this problem, it's means. And in this case, we're measuring the true mean measurement of a critical dimension of an engine crankshaft. All right, in terms of the conditions, the independent condition, big N, which in this case is going to be all engines. That has to be greater than or equal to 10 times 16, so that's 160. Well, in this problem, it says that there's more than 200 produced, so that is definitely reasonable. The normal condition is that our sample size is greater than or equal to 30, which it's not. It doesn't say anything about being from a normal distribution. However, when we put this data into a GeoGebra and check our normal quantile plot, the normal quantile plot is linear. So we would say normal quantile plot is linear, which means that it is approximately normal. And then for the random condition, it does say SRS. So SRS is stated. All right, so now let's do our calculations. So this is a problem about means. So it's going to be x bar plus or minus t star times s over the square root of n. So x bar is 224.002 plus or minus 2.131 times 0.0618 over the square root of 16. And then when we put that in our calculator, our margin of error ends up being 0.0329. So when we subtract that, we get our lower bound, which is 223.97. And then when we add that, we get our upper bound, which is going to be 224.03. Instead of writing out my context, I'm just going to say it verbally. So I'm going to say I am 95% confident that the true mean measurement of a critical dimension of an engine crankshaft is between 223.97 millimeters and 224.03 millimeters. All right, now another confidence interval problem. However, this one's about proportions. So with proportions, we know we always use Z star. So let's identify our symbols first. Our sample size in this case is 150. P hat, in this problem we have to calculate. So that's going to be 89 over 150, which is 0.593. And then Z star, we're using Z because it's proportions. For 99%, it's going to be 2.576. Okay, so now we can define our parameter. So proportions is P. That represents the true proportion of Yellowstone visitors who favor restrictions on the number of vehicles allowed to enter. All right, so now let's do our conditions. So starting with the independent condition, big N, which is going to be all visitors, is greater than or equal to 10 times 150. So that's 1,500. That's definitely reasonable to assume. The normal condition, we're going to do N times P hat, so it's going to be 150 times 0.593. That is 89. That's true. And then we're going to do 150 times 1 minus P hat. And that gives me 61, which is also greater than or equal to 10. So that means we're approximately normal. And then lastly, the random condition, it does say a random sample, so that's stated. All right, for the calculations, it's going to be P hat plus or minus Z star square root of P hat times 1 minus P hat over N. So now let's plug in everything. So that's going to be 0.593 plus or minus 2.576 square root 0.593, 1 minus 0.593 over 150. So when we put the margin of error in our calculator, we get 0.593 plus or minus a margin of error of 0.1033. To get our lower bound, we subtract that. So we get 0.4897, so I'm going to say 0.49. And then when we add that, we get 0.6963, so I'm going to say 0.70. So interpreting context, again, I'm just going to do it verbally. We are 99% confident that the true proportion of Yellowstone visitors who favor restrictions on the number of vehicles allowed to enter the park is between 0.49 and 0.70.